Less than 20 years ago, Africa began to show signs of splitting apart, marked by visible fractures spreading across various countries, even dividing a man's home. Since then, it has become evident that Africa is experiencing a continental rift. Such phenomena occur when a continent is on the verge of breaking into two or more pieces. This eventuality will result in the formation of new continents, islands, and oceans, forever altering our world. But why is Africa undergoing this splitting process? What forces are causing its land to fracture? And what are the implications for Africans and the global community at large? Join us in this video as we delve into the lesser-known topic of Africa's continental divide. Back in 2005, images and reports started circulating, highlighting a continental rift unfolding in East Africa. A continental rift refers to the gradual separation or splitting of a continent into two or more parts. This natural phenomenon is not unique to Africa. Indeed, every continent on our planet owes its existence to such rifts and the movement of tectonic plates. To comprehend Africa's current situation, we must journey back hundreds of millions of years. At that time, Earth was a solitary landmass surrounded by a single vast ocean. Known as Pangaea, this supercontinent was encircled by Panthalassa, the ancient ocean. Over millions of years, the Earth's crust underwent heating, cooling, and fragmentation, eventually giving rise to the continents, islands, oceans, and seas we recognize today. The ongoing splitting of Africa's landmass is a continuation of this geological process, albeit on a smaller scale in terms of time and space. Yet, its implications are significant, potentially reshaping not only Africa, but also the entire planet. So, let's explore this fascinating journey as Africa embarks on the path to becoming two separate continents, a transformation that most people remain unaware of. Although it may appear that the Earth is motionless in reality, it is in a perpetual state of movement and transformation. What we walk upon every day, known as the Earth's crust or lithosphere, is comprised of roughly 15 to 20 tectonic plates that are continuously shifting, either moving apart or colliding with one another. These plates constitute the vast landmasses that shape our continents and islands. Imagine these plates as segments of a cracked shell floating atop the intensely hot molten rock beneath the Earth's surface. Despite being tightly interlocked due to the extreme heat from the Earth's core, these plates are in constant motion, sometimes converging and, at other times, diverging. This movement is what scientists refer to as plate motion or tectonic activity. Have you ever noticed how the eastern coast of South America seems to fit snugly against the western coast of Africa when you observe a globe? This is because these landmasses were once connected. The formation of different continents and oceans occurred when this immense supercontinent began to break apart. According to NASA's Earth Observatory, the Somalian Plate located in the eastern part of Africa is gradually shifting eastward, separating from the larger and older Nubian Plate. The Somalian Plate, also known as the Somali Plate, and the Nubian Plate, sometimes referred to as the African Plate, are both moving away from the Arabian Plate to the north. These plates converge in the Afar region of Ethiopia, forming a distinctive Y-shaped rift system, as described by the Geological Society of London. This process of the Somalian Plate drifting away from the Nubian Plate is commonly termed the East African Rift. This rift comprises a network of valleys stretching approximately 2,175 miles from the Red Sea to Mozambique. If the Somalian tectonic plate were to fully detach from the larger Nubian Plate, it would result in the splitting of the world's second largest continent into two distinct landmasses. This prospect is incredibly intriguing for geologists and scientists alike, reminiscent of the separation of South America and Africa hundreds of millions of years ago. However, such a significant event would not occur within our lifetimes, as it would take approximately 5 to 10 million years for a complete separation to occur. Additionally, a clean breakaway of the Somalian plate from the Nubian plate might not be the only potential outcome. Another scenario could involve a partial separation, where most of the Somalian plate separates from the rest of the continent. This partial detachment would result in the formation of a new sea between the two landmasses, encompassing regions such as Somalia, Eritrea, Djibouti, and parts of eastern Ethiopia, Kenya, Tanzania, and Mozambique. Additionally, there's a possibility that only eastern Tanzania and Mozambique could separate. Such rifts would benefit countries currently landlocked, such as Ethiopia and Uganda, as the emergence of a new coastline and ocean would stimulate economic growth through increased trade and production opportunities. According to Ken McDonald, a marine geophysicist and professor emeritus at the University of California, Santa Barbara, the Gulf of Aden and the Red Sea would inundate the Afar region and the East African Rift Valley, transforming them into a new ocean and a separate small continent. However, reports indicate that although the rift is discernible, it's not expanding rapidly enough to result in a complete separation at present. Its current rate of growth is approximately 1/4 of an inch per year, which Ken McDonald likens to the pace of toenail growth. But how do these rifts come into existence? And why does their formation remain a topic of debate among geologists and geophysicists? One prevailing model has gained widespread acceptance, suggesting that there's an upsurge in heat flow originating from deep within the Earth. This phenomenon is believed to generate thermal bulges, visible in regions like central Kenya and the Afar region of north-central Ethiopia, as prominent highlands on topographic maps. According to this model, these bulges stretch and fracture the outer brittle crust, forming a series of normal faults. Many experts attribute the formation of these bulges to the intense heat exerted on the Earth's crust by mantle plumes located beneath the continent. A mantle plume refers to an area beneath the Earth's crust where magma is hotter than the surrounding magma. The elevated temperature from this exceptionally hot magma triggers the melting and thinning of the overlying crust, causing the bulges to expand and fracture further. This process may also lead to widespread volcanic activity on the Earth's surface directly above the plume. Often, the stretching of these thermal bulges is preceded by significant volcanic eruptions that spread over vast areas, sometimes referred to as flood basalts. During such eruptions, lava flows along the fractures of the bulges rather than erupting from individual volcanoes, resembling the flow of water during a flood. A prominent feature observed in the ongoing rift in Africa is the presence of a rift valley. These valleys form when two tectonic plates move apart or rift. Rift valleys can be found both on land and at the bottom of the ocean. In oceanic settings, they are created through the process of seafloor spreading. What sets rift valleys apart from river valleys and glacial valleys is that they are shaped by the movement of tectonic plates rather than erosion processes. Many rift valleys are situated at triple junctions, occurring when three tectonic plates converge at approximately 120-degree angles. In such instances, two arms of the triple junction often diverge, ultimately forming an entire ocean, while the third arm, known as a failed rift or Oerlikon, may evolve into a rift valley. A classic example is the formation of the Atlantic Ocean. Originating from a triple junction in what is now the Gulf of Guinea on the west coast of Africa, two arms of the junction initiated the creation of the ocean, while the Oerlikon generated the rift valley known as the Benue Trough in present-day southern Nigeria. Rift valleys can also be found beneath the ocean's surface, frequently dividing lengthy mountain ranges and termed mid-ocean ridges. These ridges emerge when tectonic plates separate at mid-oceanic locations. Magma from the mantle rises and solidifies upon contact with the cold seawater, forming new oceanic crust at the base of the rift valley. Along the northern mid-Atlantic ridge, for instance, the North American plate and the Eurasian plate are diverging at a rate of approximately 1 inch per year. Over tens of millions of years, the Mid-Atlantic Ridge has given rise to rift valleys spanning up to 9 miles in width. In the Pacific Ocean, the East Pacific Rise has generated rift valleys where the Pacific Plate is moving away from the North American Plate, Cocos Plate, Nazca Plate, and Antarctic Plate. Characteristic of many underwater rift valleys, the East Pacific Rise hosts hydrothermal vents formed by geological activities beneath the rift valley, releasing superheated water and fluids into the surrounding ocean. A rift valley similar to the East African Rift but located nearby is the Great Rift Valley, which is arguably the most renowned rift valley globally. Extending from the Middle East in the north to Mozambique in the south, the Great Rift Valley is characterized by its geological activity, featuring volcanoes, hot springs, geysers, and frequent earthquakes. The East African Rift comprises two primary branches, the Western Rift and the Gregory Rift. These rift valleys are punctuated by various volcanoes, from Ethiopia's Erta Al to Kenya's Mount Kenya, now an extinct stratovolcano. Additional notable volcanoes include Ol Doinyo Lengai in Tanzania and Mount Kilimanjaro, a dormant stratovolcano in Tanzania, as well as Mount Nyiragongo in the Democratic Republic of Congo. The Western Rift, also known as the Albertine Rift or Lake Albert Rift, encompasses the East African Great Lakes and is among Africa's most biodiverse regions. It boasts snow-capped mountains, savannas, highland forests, and several picturesque lakes. Conversely, the Gregory Rift, named after the geologist who first mapped it, stretches from the Red Sea and Arabian Sea southward to Mount Kilimanjaro. An integral feature of the Gregory Rift is the Afar Triple Junction, where the Horn of Africa intersects with the Red Sea and the Gulf of Aden in the Arabian Sea. At this junction, the Arabian Plate, Nubian Plate, and Somali Plate are all diverging from each other. Notably, the two arms of the Afar Triple Junction continue to widen through seafloor spreading. One arm extends into the Red Sea, while the other extends into the Gulf of Aden. As these rifts progress, the depression created by the Gregory Rift could potentially become submerged by the Arabian Sea. Should this occur, the resulting landform, the Horn of Africa, would transform into a continental island akin to Madagascar or New Zealand. One fascinating aspect of the East African Rift is that despite both the Western and Gregory branches originating from the same geological process, they exhibit distinct characteristics. The Gregory Rift is marked by heightened volcanic activity, whereas the Western Rift features deeper basins hosting large lakes and abundant sediments. Notable among these lakes is Lake Tanganyika, the second deepest lake globally, and Lake Malawi, where basalt eruptions and active crevice formation have been documented. Geologists have recently turned their attention to the East African Rift system to observe firsthand how ocean basins form on land. This presents an exciting opportunity for scientists to directly study the mechanics of rift formation, a prospect unavailable elsewhere in the world, where most rifts have either filled with sediments or become submerged. The East African Rift system serves as an exceptional field laboratory for investigating a modern, actively evolving rift system. Lakes often emerge as prominent features within rift valley systems. Rift lakes form when fresh water accumulates within a rift valley. An illustrative example of this phenomenon occurred over 1 billion years ago when the North American Plate began to rift, leading to the formation of a triple junction within the developing continent and the subsequent emergence of a deep rift valley. Over time, fresh water accumulated within this rift valley, resulting in the creation of Lake Superior. However, the rift failed to fully separate, and the continent retained its integrity, with the rift's arms unable to detach and form a new ocean. Today, Lake Superior rests atop one of the oldest and deepest rift valleys globally. Another notable rift lake is Lake Baikal, acclaimed as the deepest and oldest freshwater lake worldwide. Its deepest sections plunge to approximately 5,387 feet, and over the past 25 million years, layers of soft sediments have gradually accumulated on its bed. Remarkably, The actual floor of the Rift Valley reaches depths exceeding 3 miles. Lake Baikal also boasts the largest volume of freshwater on the planet, estimated at a staggering 5,700 cubic miles. Another illustration of a rift lake formation is the Dead Sea in the Jordan Rift Valley. Although not the world's deepest lake, the Jordan Rift's profound depth renders it the lowest land elevation globally. The surface of the Dead Sea sits at 1,407 feet below sea level, with the lake plunging approximately 997 feet deep into the earth. However, unlike Lake Baikal, the Dead Sea is not a genuine rift lake, as the underlying rift did not fully develop. Instead, the area is characterized by the Dead Sea Transform, a geologically intricate zone where tectonic plates interact in various ways. Among the most renowned rift lakes globally are those nestled within the rift valleys of the East African Rift, commonly known as the Rift Valley Lakes. Spanning from Ethiopia to Malawi, these lakes are celebrated for their remarkable biodiversity. Among them is Lake Tanganyika, whose shores border Burundi, the Democratic Republic of Congo, Tanzania, and Zambia. This lake harbors hundreds of endemic species of cichlid fish. Conversely, Lake Natron in Tanzania is one of the shallow, alkali-rich soda lakes of the East African Rift, renowned for its striking red hue attributed to pink salt-loving bacteria residing in its saline waters. Another noteworthy lake is Lake Malawi, also referred to as Lake Nyasa, ranking as the third deepest freshwater lake globally. Situated at the southern end of the western arm of the East African Rift Valley, Lake Malawi's basin is densely populated and afflicted with a high prevalence of waterborne diseases. Yet, boasting approximately 800 to 1,000 fish species, it stands as the world's most species-rich lake in terms of fish diversity. As the East African Rift continues its journey of dividing Africa, the region has garnered significant attention from stakeholders ranging from geologists to ecologists and government officials. The Rift Valley has become a focal point for understanding the unfolding of human evolution, earning the nickname the Cradle of Humanity due to numerous hominid fossil discoveries within its bounds. These discoveries, such as Lucy, a hominin skeleton dating back over 3 million years found in Ethiopia, and Turkana Boy, an almost 2-million-year-old hominin skeleton discovered in Kenya, have sparked contemplation among scientists regarding how the evolution of the rift may have influenced our species' development. Experts believe that the structural and evolutionary dynamics of the East African Rift created an environment conducive to the flourishing of life. Furthermore, the presence of the rift likely heightened East Africa's sensitivity to climate change, resulting in alternating wet and dry seasons. This environmental pressure may have propelled our ancestors towards bipedalism and increased cognitive abilities as they adapted to these climatic fluctuations. Beyond its role in understanding continental rift processes, the East African Rift Valley holds potential as a significant energy source. The region's extensive volcanic and tectonic activities have prompted initiatives such as the United Nations Environment Programme's Geothermal Energy Program, aimed at harnessing the Rift Valley's underground heat to generate electricity through steam wells. Estimates suggest that a single well could power up to 5,700 homes, offering a sustainable energy solution for millions currently without electricity access. However, alongside these promising developments, the same volcanic and tectonic forces present challenges for inhabitants of the region. Rising water levels and the discovery of oil around one of the lakes pose additional concerns. The region's high levels of malnutrition and poverty, combined with the unpredictable nature of an active rift with its volcanic and tectonic uncertainties, present stark contrasts to the excitement of scientific discoveries. While the prospect of Africa splitting into 2 or more landmasses may not occur within our lifetime, the East African Rift will undoubtedly continue to shape our collective future in the decades and centuries ahead. Thank you for watching another episode. Don't forget to check out the video on your screen for more captivating content about space.